functions. So you need to know a little bit about function notation because when we're comparing functions, you'll see function notation. And so that k of x and g of x is function notation. There's two different farms in this problem, and it's nearing Halloween, so it's some people go to pumpkin patches during Halloween, pumpkin farms. So this one has two different farms. I think that one's called Cooper's. Is that how you say that? Kuipers? Coopers? I don't know. We're gonna call it Cooper's. Cooper's Family Farm in Gobert's, that I know I'm pronouncing correctly, because I've actually been there. Pumpkin patch. You can pick your own apples. So we're not buying pumpkins, we're buying apples. So you go to the farm and you can pick your own apples. The pricing is different each place. So not only have to pick your own apples, then you got to pay for them. Some people do this for fun. They're like, well, what can we do for fun today? Let's go pick some apples, okay? And that's our idea of fun. Everybody's idea of fun is different. You're not stealing apples. You collect your own apples and then you pay for them. So again, I've never been apple picking. I'm not against it. It's just that I don't want apples that bad to go pick them myself. But some people enjoy this kind of thing, and if that's the kind of thing you enjoy, you should do it. So Kuiper's is expressed as a graph, and Cooper's, and then Goldberg's is expressed as a table. And it says to compare them. It asks you different questions. So when you look at this question, it says determine the value of k of 1.5. If you don't know what that means, then you're just looking at that like I don't know what I'm supposed to do. I'm supposed to do what with 1.5? But you need to know when it's written like that, that is an x value or an input value. So when it's written this way, that is an x value. Now, then you would say, okay, well, which one is it? Well, it's obviously the k of x one. So you go to where k of x is 1.5, and then you would need to know that 1.5 is pounds of apples. It's not number of apples. You're not going to have 1.5 apples that you take home. It's 1.5 pounds of apples. And then you're going to slide over and say, okay, that equals 350. So when it says determine the value, that would be that 3.5, $3.50. Okay? So that's the determine the value part. And then explain the meaning in the context of the problem. We did this yesterday. We're going to do it more today. By the end of today, you should be good at this. You got to mention 3 things, okay? Just try to remember, you got to mention 3 things. You got to mention this number, and the k. So I'll do this one for us. 1.5 pounds. Somebody could accidentally write 1.5 apples. 1.5 pounds of apples costs $3.50. And that would be 2 of the things you need to say. You can't just say it costs $3.50 at Cooper's Farm. You can't just say it's 1.5 pounds of apples. You got to say cost. You got to say both those things. And then you write at Cooper's Farm. I wanted to change this PDF to be, I wanted to change this to say Sunny Acres Farm, which is near my house, and more people probably been to Sunny Acres Farm, but it's written as a PDF, and I can't edit it, so I just left it as this crazy farm name that I've never heard of, and I don't know how to pronounce. So, everybody good with all that? Okay. All right. I went to pumpkin farms as a kid to buy pumpkins, and then there was a period of probably 20 years where I didn't go to it. Then I have a child of my own, and then I'm back at pumpkin farms. So that's kind of how your life might go. If you have younger brothers and sisters, maybe they get more excited than you about going to the pumpkin farm, or maybe you love pumpkin farms. I don't know. But if you think you'll never go, you might have children and go to buy pumpkins at pumpkin farms and pay $10 for a pumpkin that you can get at Jewel for $8. Okay, anyways, which is greater, K of 2 or G of 2? So you find both of these. You go to where K of 2 is, that's $4. And you go to G of 2, which is just looking at the table. So if you know what to look for, that's not hard to do. And so it's not a bad idea when you're doing this to write these down. Sometimes people write the wrong answer, and they don't have anything shown there. It's just wrong. If you have some correct math and the wrong answer, you could get partial credit. So I would write those down and say like k of 2 equals 4 and g of 2 equals 3. And then it says which is greater. Now, some people can misinterpret this. Which is greater doesn't mean which is the better by. So 4 is greater than 3, right? Mathematically, 4 is a bigger number. So don't be like, well, oh, Goldberg's is cheaper, so it's greater, it's better. I mean, it's better to buy 2 pounds of apples at Goldberg's, but that's not what they're asking you. So it says justify your answer, explain the meaning and the context of the problem. So I'm going to write it like this. 2 pounds of apples costs $4 at Cooper's and $3 at Goldberg's. Bless you. And then this is obvious, so Cooper's is more. And if you don't write all of that the same way as me, that's okay. If you're saying Cooper's is greater and you have little explanation, but you have this written down, I would accept that. So if you have that written down and you're just like Cooper's, I would accept that because that's not exactly what you're supposed to say, but you have a mathematical justification. It's written in symbols and not in words, but it is a justification. So the best thing to do is just write all of that, and then you can't go wrong. Okay, everybody following along so far? All right, this next problem, again, they don't know what they're asking you for. They're asking you for something that's simple to understand, but it's written in symbols that are not that easy to understand. So, if I said this without the symbols, it would be easier than the way it's written. So it says, for what value is k of x equal to g of x? What they're asking you is, for what value of x are the y's the same? So for what input, what value of x, are the outputs the same? In other words, in terms of apples, for how many apples are the prices the same? That's what they're asking you, okay? So like if you don't know what they're asking you, you won't know what to write. But if you know what they're asking you, you can figure this out. I want to know for how many apples are the prices the same? Now, I'm going to give you a strategy for this, but you can kind of just bounce back and forth and look at these numbers and look at these numbers and figure it out. There's only one number that's the same. Have you figured it out already? We yell it out. What is it? 4 and 6. Okay. So there's a strategy you can use that will, I don't know if it'll save you time or is worth doing, but if you have a table and a graph, you can take the table values and just plot them on the graph. So I'm going to overlap this, and so I'm going to plot these points. Now I'm going to do it kind of fast here, so you don't actually have to do it right now, but just know this strategy of you can plot these points, and some of them I have to kind of estimate, but eventually some of them are really close. 4 is at 6, and I can see I get the same number. So they're both linear, and so eventually they'll both hit at one point, and I could do another one of these, but I get 4 pounds of apples is the x. Everybody okay with all this? Okay, so for what value, we can just write x equals 4. Then it's explain the meaning of the answer in the context of the problem. When you buy 4, and again, watch what you say here, because sometimes people say, when you buy 4 apples, it's 4 pounds. If you just say 4 pounds, you don't need to write of apples, that would be okay, but I'm writing of apples. 4 pounds of apples. And then you could either write the costs are the same. What's another way of saying that? Or I guess you say a different way of saying, instead of saying the costs are the same, I could say the costs are Well, they're not less or greater. They're equal. So besides saying they're the same or equal, I can say the costs are both
The same.
$6. $6. When you buy 4 pounds of apple, the costs are the same. And you know, if you write both $6, that's the or equal or both $6. There's different ways of saying the same thing. But if you're like, I would write the costs are both $6. That's fine. That's good. That's a good answer. Okay. I just want you to hear some different things. Which farm would you rather go to in order to pick apples? So this one is an opinion question. Is there one that's always better than the other? Yeah? Which one do you think is always better? I think Go-Bird's always better. If you were buying 40 pounds of apples, you'd go to Go-Bird's.
Yes.
No.
So these go up by 75 cents every half pound, which is $1.50 every pound. These go up when you go from 1 pound to the next by $1. So one's going up by $1.50 per pound. One's going up by $1 per pound. No, I said that wrong. One's going up by $1.50 and one's going up by $1.75 per. Let me say this again. Hold on. This one's $1.50. What was this one? $1. Okay, I got it now. One's going up by $1. One's going up by $1.50. This Cooper's Farm, that $2. How would you explain that? Like, why is Cooper starting at $2? Like, if you went to the farm, they're explaining their pricing. How would they explain that? Yeah. Yeah, it's like a $2 fee of just getting started. Like you pay that $2. It could be like you could think it was tax, but it's not really tax. It's like it's a $2 entry fee or starting fee or service charge. You know, like when you buy online tickets and they're like, this is the convenience fee of $3.50. You're like, oh, that was really convenient for me. Thanks. So it's like that extra fee that has nothing to do with the pounds of apples. So if you walked out and there were no apples, you still did pay them $2. So I'm just gonna write this down. It depends, and you could write whatever one you want. Depends on how many apples you buy. How many? Yeah, you're right. How many pounds of apples you buy? You're right, but it wouldn't be really wrong to say how many apples, right? Because the amount of apples would affect the amount of pounds. So it depends on how many apples or pounds of apples. I think it would be safe either way. If you said, Kuipers because I hate apples, that would be an okay answer. Or you write Go-Birds because I would buy 1,000 pounds of apples, then that would be okay too. Okay, so that one's your opinion. Which goes up fastest? Go-Birds. And do you agree that having the graph of Go-Birds really helps to tell that it goes up faster? Versus these numbers. So that's another reason why I like to graph it, because I could see that Go-Birds is definitely going up faster. All right, so we're done with that problem. You don't have to explain that. You don't have to explain the Go-Birds. Read this next problem. So you have two different people, two different pools. Some of you have been to water parks. Sometimes there's a kid's pool and a wave pool, or a pool that's under the water slides, and then another pool that maybe is, for something else. There's different pools. So imagine there's two different water slides, and they each have a little pool at the end. And you can imagine it that way. Or you can imagine two giant pools, however you want. But they're two different pools, two different people. Now, it doesn't really say if this is Allie, like a girl's name, or Ali. I don't know. What are you guys thinking, Allie or Ali? Ali. Okay, so I've always read it as Ali and David. I don't know, but if you're thinking that's Allie, whatever, it doesn't make a difference. Okay, so if you were thinking it's like Allie, like short for Allison, that's fine. Whatever, doesn't make a difference. I'm gonna say Ali, but you can do it either way. So Ali is A of X and David is D of X, and you have their two graphs. And it just says make as many possible observations as possible given the graph above. So we're just going to look at these things and write down different things that we notice. There's some things that I want to say for sure. And, you know, I would say there's probably 5 things that we need to mention. And, you know, if we say more than that, that's okay. But somebody just tell me something that they look at this graph and that they would notice. Ruby, go ahead. Okay. Ali starts with more water, for sure. And you can word that a lot of different ways. If you said he starts with 4,000 gallons more, you know, that's fine. He does start more. Ali starts with more. You got to notice Ali starts with more. These are the starting amounts. 0 minutes is when you start. You start at 0. If you're doing a stopwatch, the stopwatch would say 0, you press the button. That's how much water would be in each pool. Ali starts with more. Now, we don't have to say David starts with less, okay? If we say Ali starts with more, that we assume that means David starts with less, okay? So that's not necessary to write David starts with less. If you want to write that down, go ahead and write it down. David starts with less. All right. What else you got? Go ahead. Okay.
Ali drains his faster.
Ali is going faster. Ali's water is draining. Maybe we say his pool faster, but it's going faster. So again, a lot of different ways to word that. But Ali's, I'm gonna change it to pool. Ali's pool is draining faster, or Ali is draining his pool faster. His line is steeper. Steeper is faster. Okay? Steeper is faster. Whether it's going up or down, steeper is faster. So in this Gobert's one, this one was steeper, it's faster. This Ali one, that one's steeper. These are both going down, it's faster. Okay. He also gets more water out in less time. So it's definitely faster. Okay. What else you got? We said Ali's going faster. We didn't say anything about time here. So I want to talk about these 2 points. Ryan. David takes longer. Yeah. More time is fine. Again, different ways of wording this. Ali takes less time. David takes more time. Ali goes. We already know Ali goes faster, but there's a difference between going faster and taking less time. So I could have a really steep one that starts a lot and ends after David. Just because it's steeper doesn't mean he beats David. I could have a person who starts with this and goes really slow and finishes first. So the fact that Ali is faster doesn't automatically mean he takes less time, because you can take more time and still be moving faster if you start with more. In a race, you know, if you give somebody a head start, you might run faster than that person, but they might beat you because they had a head start. So those are 2 different things. Ali is faster, and Ali ends sooner. Those are 2 different things. They don't have to be both true. So we have to mention both of those. Okay, there's one other thing we have to say here. Ruby? Yeah. There's this intersection point here, and it's in about 10 minutes. I can't really tell exactly what that is. So Ruby didn't mention that Y value, so let's not even bother with that. At 10 minutes, they have the same amount of water in their pools. You could say in their respective pools, if you wanted to, but that's good enough. Pools. Okay. think that's it. I think there's only 4 things we had to say. Because like I said, David starts with less water and David going slower and Elite taking less time. Those are kind of stated in this. So I think that's good enough. I think that's good. Okay, so you guys came up with everything that was necessary to notice there. And we are going to stop there.